What is up, mathletes? Welcome back to the episode of Math with Dr. Math. And what do we have today? So today we're going to be looking at periodic functions. All right, so I'm going to give you some insights of how these graphs are transformed. So are they shifting up? Are they shifting down? Are they shifting left? Are they shifting right? How do I know? All right, and just to make this video nice and short, I'm going to use MissBillgard.com, and so let me teach you what's going on here. All right, so for this worksheet, notice they want us to verbally tell the audience what's going on, and then to write an equation that represents this transformation. All right, so the given graph that we're going to start with are these dotted curves. All right, and what we want to do is we want to say, how do we go from that dotted curve to the solid curve? All right, so let's look at our first graph here. And we see to get to the dotted curve, to the solid curve, what I want you to do is to pick a point on the curve. So look at this point 0, 0. And what happens is, pretend you pick up this graph and you move it. It seems like this graph was moved 2 places to the right? That this point was lifted and placed right here. So every point on this dotted curve, look, it got transformed. It got shifted 2 units to the right. All right, so it has a horizontal transformation here. So it gets horizontally transformed right 2 units. So usually I'll just say it got shifted 2 units, but again, that's the language you heard there. So let's look at what's going on in here. So when you move your function to the left or to the right, what happens is your x coordinate is being impacted. So because I'm going to the right 2 units, what we got to do is you take that x value and you subtract 2, and it's kind of counterintuitive, isn't it? And the way I like to tell my students is like, what number would you plug in here to get back to 0? And you would plug in a positive 2 here to get back to your starting point. So for your notes, make sure you put that f of x minus 2. It's counterintuitive, so what it means is you shift your graph 2 units to the right. And of course, if you shifted your graph 2 units to the left, then it would be f of x plus 2. So when you add a number, it gets shifted to the left. When you subtract a number, it gets shifted to the right. So make sure you got that down. All right, so let's look at number 2. What's going on with number 2? Again, we're starting with the dotted line. So we could see here that this dotted line, this function is getting stretched, right? So notice the height right here is 2, and all of a sudden, the new height when it gets stretched is up here at 6. So you could just divide these two, and that's our that's going to be our scale factor here, what we're going to multiply it by. So our dilation factor. So it's a vertical dilation, which means it's either getting stretched or compressed if it's less than 1. But in this case, we're multiplying this 2 by 3 to get to that 6. And again, whatever number you stop at, you just divide these 2 numbers to get that 3. So whenever you're stretching something, that means you're multiplying it by a number that's greater than 1. So here, we're just taking the original function. Notice it didn't move to the left, it didn't move to the right, it just got stretched. So that's why you just multiply it by 3, by what it got stretched by. All right. So number 3 here. So what's going on with this function? So if we notice that this function, notice it's a dotted line here. And let's pick a point. So let's pick, look what the height right here, the dotted line is at 3. So now what I say is all of a sudden it's getting kind of compressed. It's getting horizontally compressed, right? So the dilation, the horizontal dilation, right? That's what's either stretching it or compressing it. And because it's being compressed, you're gonna multiply it by a number less than 1. What number do we multiply it by? Well, this is where we need some points here. So as I look at this, notice the x value is 3. But now for this new height, the x value is half of that. It's 1.5, it looks like, right? It's 1.5. So what happened is that x value got cut in half. So that's our horizontal dilation, is you multiply it by 2. And remember what we just said, whatever happens with our x dilation, with our horizontal dilation, whatever's happening in the inside of the parentheses here, it's counterintuitive, the opposite is taking place. So even though our original function got cut in half, what that means is you're going to be multiplying it by 2, all right? And let's say it were this, or instead of a half, let's pretend that it actually got stretched, horizontally stretched by a factor of 2. Then this would be the opposite. This would be the 1/2 in here. So just remember the relationship between these two when we're talking about horizontal movements is counterintuitive. So this one is 2x because, again, it's the inverse of this, if you will. Alrighty, so let's continue the march. So now, how did I get from this dotted line, our dotted curve, to this solid curve? All right, so notice it looks like I didn't go to the left, I didn't go to the right, right? We didn't shift it, and we didn't stretch it. So what happened is this point, I drop it 1, 2, 3, 4, 5 units. So because you had your original height, which is f of x, and you dropped that height by 5 units. So you dropped it 1, 2, 3, 4, 5 units. So that's why we subtracted 5. So vertically, it got shifted 5 units. All right, so that one is pretty nice. Let's look at this one. We got a lot going on here. All right, so I always start from the middle. It's easiest at this origin, and then I try to kind of find where's the origin now on this graph. So I could see that the new origin is like right here. So this graph, we could see it kind of, it got moved to the right, and then it got shifted down. So 2 things were happening here. So it got moved to the right, let's see, 1, 2 units, right? That's how many, if I had a pickup, pretend this was like a piece of wire, and to lay it on top of this piece of wire, I'd physically pick this up and move it right 2 units, and then down 1, 2, 3, 4, 5 units. So because I moved it to the right, remember what that impacts. That impacts what's inside of the parentheses here. So that's why we have x minus 2, because again, it's always counterintuitive. And because I'm actually moving it down 5 units, that's why I have the minus 5. So it got shifted down 5 units, or transformed, whatever word you want to use, and we move it right 2 units. All right, so there's that one for you. And number 6. So for sure this one got stretched, right? Because look at the height. This height was 2, but then the height of the solid line was a height of 6. So one thing we know is that it's going to have the dilation. We're multiplying it to get to 2 to 6. You have to multiply it by 3. So the vertical dilation, that's what stretches it. It gets multiplied by 3. So we're going to have a 3 on the outside. All right, so that's where this 3 comes into play. And then notice, how did I get from this peak to this peak over here? So I had to move it 1, 2 units to the right. And because, notice, from this peak to this peak, and I'm looking at the x direction, to get from this x value to this x value, I have to move it 2 places to the right. And so because you're moving it 2 places to the right, that's why, again, it's counterintuitive. Inside of a parentheses, you have the x minus 2. So whatever is inside of your parentheses, remember, that controls the left and the right movement. Whatever you have outside of the parentheses here, what you add and subtract, right? That's controlling your shifting up and down. And if you put a number in the front, your dilation, if it's greater than 1, you're stretching it. If it's less than 1, you compress it, you shrink it. All right, so a lot of things going on here. And then of course you have your horizontal dilation, just like we saw here. So when this number is bigger than 1, you're gonna see your graph get horizontally compressed. And if it's greater than 1, you would see it like a a spring, a sling. What's, I don't even know. I forgot, the slingy. No. Anyways, you get that thing being, that accordion being stretched out, and I'll go figure out what word I was trying to say right now. So hopefully this was helpful, folks. Make sure you like the video, subscribe, and we'll see you in our next video. Peace. Alright, mathletes, thanks for watching, and again, if you like this video, we have some other videos that we think you might enjoy. Thanks for watching, and we'll see you guys next time.